A brand new space telescope is about to transform our understanding of the universe, and it's almost ready for the launch pad. NASA's Nancy Grace Roman Space Telescope is a first-of-its-kind observatory on a mission to map the universe one panoramic frame at a time. And better yet, it's ready to go 8 months ahead of schedule. Joining us now to tell us all about this technological marvel is Jason Hyland from NASA's Goddard Space Flight Center in Maryland. Jason, good morning. Thank you so much for joining us.
Good morning. Thanks for having me.
Well, first, you're all dressed in, you got the mask on and you have the outfit on here. Why? What's going on?
So we're actually broadcasting this from our clean room here at the Goddard Space Flight Center. This is the largest clean room of its class in the world. And this is where we've been assembling the Roman Space Telescope for the last several years.
I love it. Let's start.
And the suit itself, actually helps protect the telescope by keeping anything that would come off my clothing or skin or hair or anything like that from getting on the telescope.
That makes total sense. We have that when when people are making computer chips up here in the Pacific Northwest and things like that.
Exactly.
So let's take a look at the telescope behind you here, a live look. It's about the size of a semi-truck trailer, and it has a camera the size of a refrigerator. So tell us about some of the cutting-edge technology this telescope is carrying.
So we have two instruments on the telescope. One is called our wide field instrument. That's the one that has the camera you were talking about. That camera has 18 4K detectors to make up a 300 megapixel camera, which has a wide view into space. And so the Nancy Grace Roman Space Telescope will actually get these wide images of space, about 100 times the area that the Hubble Space Telescope can see at any one point in time. And we'll be able to move and map the universe 1,000 times faster than the Hubble Space Telescope can with that particular camera. And one of the things that we expect to learn is to unravel some of the mysteries about dark matter and dark energy. Our other instrument is called a coronagraph instrument, and that's going to be used to block out the light of a star so that we can start to look at the reflected light off of planets around stars.
That's incredible. Now, how is this going to work with those other observatories like Hubble and James Webb Space Telescopes?
Good question. So kind of think of it as opening up a toolbox, right? And you have multiple tools that can do different things or similar things, but different, like having a pair of tweezers or pliers or a vice grip. Our telescopes have some complementary features, but they do unique things. So the Hubble Space Telescope looks a lot into the ultraviolet range and visible. The James Webb Space Telescope looks into the infrared really deep with a big mirror. And the Roman Space Telescope will also look into the infrared, but it will do so with a much wider field of view than any of the other telescopes that we have right now. And so at times we may look at something and say, hey, we just saw something really interesting. Maybe we should use one of our other telescopes to look at it in precise detail for a very long period of time.
Now, Roman will investigate something called dark energy. So tell us a little bit about what dark energy is and how will Roman help us understand something that's invisible?
So the universe, conventional wisdom says the universe started as a big bang and exploded. It was expanding. Scientists thought eventually that would slow down and start to contract in on itself over billions of years, of course. What we're finding is that the universe is not slowing down and it's not starting to contract. So that would kind of be like you or me throwing a ball up into the air, and instead of it coming back to our hands, it rocketing off into space. So the universe behaves a lot differently than people think it should based on what we can see of the universe. So we think there's a tremendous amount of mass and a tremendous amount of energy in the universe that is invisible to us, hence the name dark. What the Roman Space Telescope will allow us to do is take an unprecedented look at space and map it in 3D over and over and over again. And so we'll be able to look at the things we can see and infer what things are there that we can't see based on how they impact the objects that we can see.
All right, so what happens next, and is there an official launch date?
So we are working towards a launch in early September. Next couple of steps are to finish up just a little bit of work here at the Goddard Space Flight Center. We ship down to the Kennedy Space Center. We will do a few closeouts there, do a couple of quick checks to make sure everything was okay after shipping. We launch early September, and it takes about a month to get out to our orbit and about 90 days to actually go through the process of turning the observatory on, getting the instruments on, calibrate it, make sure they're all working correctly. And then towards the end of the year, we should start to see our first images.
I love it. I cannot wait to see those. Jason Island at NASA's Goddard Space Flight Center, thank you so much for giving us a sneak peek of the Roman telescope.
Absolutely. Thanks for having me.